Karl, you have a bunch of additional items and ideas for quorum queues, so tell us about them.
Yeah, so this is my favorite kind of features, that all the ones that haven't been written yet, because they're so full of promise, right? They're perfect, they work really well. There's no caveats, there's no awkward configuration. They're great stuff. Joke aside, so when we I'm going to share my screen. I think it's this one here. So when we make changes to quorum queues, to the actual queue logic itself, we need to do it in a quite it's not too awful, but it certainly is not just a matter of editing files. So because quorum queues rely on each member calculating the same state based on the same logs, right? So what a quorum queue replicates is a log of operations, and it makes sure that the log of operations is the same, but then calculating the queue state based on the log of operations needs to also be the same. So if there is local changes, say, for example, you upgrade one node and make a change to the logic, that will calculate a different state based on the same operations, and that's unacceptable. So we need to be careful when we make changes to quorum queues. We have RA has an internal state machine versioning feature, so where you can indicate that you have a new version available, but it won't run that version until a majority of the members run that version. And then it will switch to that version, and any members that haven't yet got that version available to them will stop applying. It will continue with replication, and then we'll continue with providing a quorum, but they won't apply their logic because they can't, because they don't have the right version of the state machine. But the assumption is that sooner or later you will upgrade that node as well, and it will all catch up at that point. So because of that, because of the way we have to develop things, we try to batch new features and changes we want to make to the state machine so that they all fit within a single new state machine version. So we create little lists of things that we want, and this is some of the things that may or may not be included in the next set of changes that we make to quorum queues, to the logic itself. So I'm just going to go through and just have a little talk about each of the features and where they're coming from. So the first one, pausing consumers. So this is kind of a feature looking for a use case to a certain degree, which is kind of why I want to share it as well, if anyone has a good use case for pausing consumers. So that would be effectively the same as in AMQP 1.0, draining all the credit, but doing it from the server side. So you say no further messages will be assigned to this consumer, even though it hasn't got any, even if it's still up, even if it's still got a prefetch available to it, we're just going to pause it on the server side. I'm not sure exactly how it could be used, but it could be useful. And it was a feature request that came in through the mailing list, and I thought it was quite interesting. Not too hard to implement in the way that it's been done. So if anyone's got a good use case for that, then
I have one.
You have one? Okay, already.
So the team at Bloomberg have developed this smart proxy for messaging, specifically for MQP 091, but I think the same ideas can be transferred to other protocols RabbitMQ supports. So one of the features they offer is blue-green upgrade automation, where your clients, so the way a proxy works, just in case I describe it, so you have a bunch of clients that connect to this proxy. It connects to a bunch of upstreams. In fact, it can be configured to connect to different clusters. And then you can pause all traffic for a group of apps, maybe for a specific virtual host, for example, reassign them to a different cluster and resume. And your applications, assuming that you do this before the Heartbeat timeout hits, your applications have just been transferred to a different cluster without stopping, without losing any connections to the proxy, that is, without even noticing. So this is why, well, maybe not RabbitMQ itself, but at least this kind of proxies need this feature. And I guess a smart enough proxy would be able to first instruct quorum queues, maybe streams as well, to pause, and then do whatever it does when it has to pause some of its clients. Other than that, all the attempts to manage flow control from applications, for example, usually ends up not working very well, at least as well as some folks expect it to be. So yeah, I tend to be equally, well, not pessimistic, but at least cautious about introducing this feature because it's a feature in search of a problem.
Yeah. Yeah, well, could be interesting. I'm sure we can find a way of using it. Right, I'm going to move on to the next one. So I have in prior content explained why we don't have priority queues inside a quorum queue. And it's partly, you know, we got a lot of things for free using Raft, but there was a few things we had to sort of pay for. One of the sort of downside is that we have to make progress on the oldest messages on the queue. We can't leave messages indefinitely in the queue whilst processing the newer ones. We can't leave like a single really old message because that will sort of affect how quorum queues are able to snapshot and truncate their log in a timely manner. So if you had a priority queue, for example, like the priority queues in classic queues, which are very strict priority queues, if you have a low priority message in there, and then only get high priority messages and always more messages than the consumers can handle, no one will ever process that low priority message, which means that we can't snapshot. But it's still a highly requested feature to have some degree of prioritization inside the queue itself. We tend to sort of fend people off saying that they should use multiple queues and then use sort of consumer resource deployment sort of quotas to determine their priorities. There are some problems with those solutions, even though in many ways I think they are superior. But we could consider adding a weaker form of priority queue, a priority queue which is sort of like I think it's referred to as a fair sharing queue, where yes, you have a higher priority, but it won't block the lower priority messages from being processed. It will just favor higher priority messages as a general rule. So maybe it will take 10 high priorities and then 1 low priority, even if there are more high priority messages available. So in that way, if we had that in there, we will still make progress of the oldest messages in the queue, and we'll still be able to make progress, even though it might sort of require a little bit more on disk storage for long backlogs. And once you say you can have this fair share priority queue, and it's like, I mean, how many priorities do you need to support? Realistically, I'm not sure users that use priority queues get that good a service from them, because it's highly dependent on ingress and the timing of consumer acknowledgements combined with the size of the consumer prefetch, whether you actually get much of a priority processing happening. I think there is value in having 2 priorities, like a low and a high. After that, I think the value compared to the complexity of the implementation starts going down quite steeply. at least from an intuitive point of view. I think it's going to be difficult to distinguish 5 separate priorities, like from a benefit point of view on the outside. 3, maybe if you sort of have slightly artificial processing, but certainly a high-low type of queue is easy to implement, easy to make sure that it's correct and that it does make progress on all the oldest messages and doesn't sort of lag too far behind. So that could happen, quite likely to happen in the next generation, I would say. I'm sure people will ask for 3 priorities, but if they can't make it work with 2, I don't know, maybe they need multiple queues, which is still
Am I right to think that you will offer a lever, a dial to prioritize high versus low? And like, what would be the limit you say as a unacceptable? Like, because people will try to push high to 100%, right? They will try to do that.
Right. So like a weighting, like a weight to how much.
Yes.
Yeah, I mean, we put sensible limits on it, but I don't know what limit would be. You sort of have to test it. The throughput limits matter as well a lot, and the amount of, yeah. I mean, it's quite likely that say in a strict queue, you could say you have a consumer with a prefetch of 100, right? And there's plenty of messages in the low priority queue, and they run out of messages in the high priority queue. All of a sudden, they're going to get 100, right? They're going to end up with 100 low priority queues in their pipeline, like in the client's internal queue, right? And then a high priority message comes in, right? They don't really get what they asked for anyway, unless they're using a prefetch of 1, at which point it would be so inefficient, they're not going to see a very high throughput anyway. So I don't really know why they bother with priority processing. So what's, I don't know, 5 to 1, something like that. I mean, I would favor a lower one. I maybe default it to like 2 to 1, 3 to 1, or something like that.
I just anticipate people coming to the issue board asking for more.
Yeah, I'm sure they will, but it's okay to say that they can't have it. I mean, that's one of the hardest thing when you're developing a product is that you have to learn is say you can't have it. Sorry, at least not yet. Anyway, let's move on. I'll use unduly high priority to this particular issue. The next one, consumer return ordering option. So, okay, we again, this is a complexity versus benefit kind of lack of feature. So quorum queues have 2 queues internally. They have an incoming queue with the ready messages that have never seen a consumer. And they have another queue called the return queue of all the messages that have been to a consumer but had to be returned for some reason. They were nacked, or the consumer crashed, or whatever. And the ordering of the return queue isn't the same order as those messages necessarily were when they were in the ready queue. So the return queue is in order of return order. And this is done because reordering stuff could be expensive, especially if you've got a lot of returns going on. Most of the time you won't notice, right? So if you've got multiple consumer, you're already accepting that you're going to do unordered processing to a degree, right? We'll always process the return queue before we take any messages off the other queue. Of course, the return messages are prioritized because we want to make that progress on the oldest messages in the queue, and the return messages are always the oldest messages in the queue, but they're not ordered in the order they were originally. Some people notice that mostly when they just sort of click around the management UI, you can notice it. It's hard to notice in the client application because, as I said, you're already accepted that you do an unordered processing if you have more than one consumer. If you have a single active consumer, you can still notice it in the management UI, but the actual consuming application won't notice it because if it crashed and had to return all the messages it had out, it will be returned in the order they were given to the consumer, which is the order they already were in. So you can still achieve ordered processing if you use the single active consumer feature. But anyway, I was thinking perhaps in order to satisfy people, and they could have an option to reorder the return queue before we pick from it, according to the original order, which we have available. It's the raft index. Right? We store the raft index inside the queue. We know what order things arrived, right? It's in the order of the raft index. I think it should be optional and opt-in, because it's just unnecessary in most cases. So that's just a little thing. This is a bit of a unusual one. Again, not really looking for might be looking for a feature again, but an option to return messages without increasing the delivery count. And one of the things we added to quorum queues early on that classic queues doesn't have is a count of the number of times they've been delivered to a consumer. So with the classic queues, you can get the whether they have been delivered as a Boolean, but you can't get the number of times. So you couldn't write your own poison message handling, which very easily, unless you just want to throw it away after a single attempt. But every time we return a message, independent of the reason we return the message for, we will increase this count. And AMQP 1.0 has have a few different reasons for returning a message to the queue, or the gesture is called a disposition. If you use the release disposition, the spec says you shouldn't increase the delivery count. So it's basically like taking a lock and then sort of just backing out of it without saying that you've done anything. I'm not sure exactly what it would be used for. I have a couple of ideas, but again, we'll see. That's something that we might just do in order to support the gesture in AMQP 1.0 better, without sort of necessarily know exactly what it's for. Next one, consumer timeouts implemented in queue. Right now, we have a very popular feature, and I say that slightly ironically, called the consumer. Is it called a consumer timeout? Whereby a channel would be closed if a message remains unacknowledged for more than something like 30 minutes by default. It's implemented in the channel at the moment. It's not implemented for things like in native MQTT and things like that. So it would be better to implement this in the queue itself, and perhaps also provide some means of renewing the lock on the message for the consumer. So yes, I'm approaching the time. I want to send something to say, can I have another bit of time? Could be abused a little bit, potentially, for people writing lock servers over queues, which I probably shouldn't be doing, but something to consider. Right. Let me just quickly scan the next one. Single active consumers honor consumer priorities. Right. Okay. Now this is a little bit more interesting, something that came in not that long ago. So when you use a single active consumer and you have more than one consumer on the queue, you will have a single active consumer. Obviously, that's what the feature is called, and you will have a queue of waiting consumer, and which is ordered by the sort of consumption time, but the order they sort of requested to be consumers. We could use the pre-existing consumer priority feature to reorder that queue so that it would be possible for a particular consumer with a higher priority to take over a single active consumer queue, and basically sort of in an ordered way, of course, but to allow it to take over and become the primary processing entity on that queue. Why would you want this? Now, what we recommend that people use single actor consumer with is often the consistent hashing exchange, where you bind multiple queues to the consistent hashing exchange. You publish messages to this exchange with a routing key, for example, their customer ID, and that will ensure that typically, unless you make binding changes, that particular binding changes, a given consumer ID will always be processed by the same consumer application. Now, the problem with that is that if you have 3 queues and you have 3 consumers and they all consume from each other's queue in order to provide consumption availability, so you take over if one of the consuming applications crashes, it's very easy to end up with a single instance of these processing messages from all the queues, right? Whoever comes first gets served first, right? So this feature would allow you each of these, consuming applications to have a home queue or a primary queue that they are the leader of. So all they do is that for the queue that they are the leader, they just consume with a higher priority, which means that even if another consuming application comes in before and starts consuming, it will take over. And so you will get eventually, if you're able to configure each application with a home queue configuration, then you can eventually end up with an even spread of consumers to queues. With a little bit of care, you should be able to do that. So this is kind of like a way of working around the fact that we don't have any sort of overarching coordination of consumers across multiple queues, like we do for superstreams, for example. So I think that could be an interesting feature. So it won't suit everyone. Not all deployment systems seem to be able to have per application configuration very easily, but you have to pay somewhere, right? Right, and the last one I find quite interesting: rejection annotations. So this is again an AMQP 1.0. You see where things are heading here, and MQTT 5.0. So when you reject a message to return it to the queue, with AMQP 1.0 or MQTT 5.0, you can supply an annotation that's going to modify the message. So you're basically modifying the message when you're returning it to the queue. So you could say, you could add some header to the message. If that message then dead lettered to a header exchange, you could route on that to a different destination for your dead lettering. So where this could be useful is in the sort of delayed retry scenario, to say you process the message, you couldn't process it, so you want to return it to the queue and process it a bit later, but how much later? Do you want an hour later, or 5 minutes later, or which one? You could modify the message on return so that it got routed by the dead lettering to an appropriately delayed queue, and then it will return to the processing queue. That's quite an interesting feature, I think. But again, there is no promises that any of these will be implemented ever.
But if someone is watching that and desperately wants one of these, make yourself known and explain why you need that, and that might help.
Yeah, make some noise.
And submit a pull request.
Yeah, but if you do, you have to implement all the features.
All right.
Awesome.
We have been on there for more than an hour.
Yeah, there were a bunch of topics that we considered discussing, but I think that's enough for today. Thanks a lot, Simon, Alex, for visiting us, I guess. And we would be happy to have you again whenever you have something to discuss, whether that's what you are working on, or if there's a topic that you just want to join and ask questions about, or whatever we want to discuss, it's for us and for the Rabbit community to just learn about what we are working on and how things work.
Great. That's an excellent incentive to publish more PRs.
That's true. All right. Thank you very much, and see you next time.